So we are talking about 9.2 measures of variation. So on Monday, I went over mean, median, and mode. The one piece that I did not talk about is finding the mean of grouped data. So that's what we're going to start with for our first example. This is a homework question for 9.1, 9.2. I don't remember which one, but it is in there. And so I wanted to make sure that I covered it. So when we look at finding the mean for group data, we first have these ranges. Okay, so we're looking at Tim's office. There are 25 employees. Each employee travels to work every morning in his or her own car. The distribution of the driving times in minutes from home to work for the employees is shown at the table. So driving from 0 to 9.99 minutes is 3 people, 10 to 19.99, 10, 20 to 29.99 is 6, 30 to 39.99 is 4, and 40 to 49.99 is 2. So in order to be able to use our calculator to calculate the mean, we first need to find the midpoints of each interval. And to make our life easier, instead of using the 9 nines, I'm just going to go 0 to 10, 11 to 20, 21 to 30, 31 to 40, and make this more readable, 31, 41 to 50. And again, that's just to keep our numbers nicer. It's not going to really change what the mid or what the mean is. So we're going to find the midpoint of each interval. So if we look at the interval 0 to 10, we're going to take 0 plus 10 and divide it by 2. So 0 plus 10 is 10, divided by 2 is 5. And that is the midpoint, the middle number for that interval. For the next one, we've got 11 to 20. So we're going to do 11 plus 20 divided by 2. 11 plus 20 is 31. 31 divided by 2 is going to be 15.5. Then we've got 21 to 30. So 21 plus 30 divided by 2 gives us 25.5. 31 plus 40 divided by 2 gives us 35.5. And then the last interval, 41 plus 50 divided by 5 gives us 45.5. So we can read you our table by saying we've got, we have L1 and L2. Again, the first column is our time. Second column is our number of employees. So now we're going to put our intervals in. So I've got 5, 15.5, 25.5, 35.5, and 45.5. And then we'll just copy down the number of employees again, because that part hasn't changed. So once we put that information, or once we calculate that information, excuse me, we can plug it into our calculator. So remember, in order to find the mean, we're going to put our information into lists 1 and 2. So to do that, we press the stat key. Under edit, we're going to press enter. And then we want to clear these out. So to clear them out, we press up and clear and enter. Go to the right one, up, clear, and enter. And for list 1, we're going to do 5, 15.5, 25.5, 35.5, and 45.5. For a number of employees, we can do 3, 10, 6, 4, and 2. And as always, you want to make sure, did I include the same number in list 1 as I did in list 2? If you don't, that's going to throw your stuff off. So then we want to run 1 bar stats. So we're going to press stat and go right to calc. and we're going to do one var stats. But because we have list 1, 2, we're going to do one var stats L1, comma L2. So remember, to get to the L1 and L2, we're going to do second 1, which gives us L1, comma, and we'll do second 2, which gives us L2, and then we press enter. And then remember, we are looking for X bar, that is the mean. We get 22.24 as our mean. So the average time for driving for these people is 22.4, which we can see here. It's in this range, and that's where most of the people are. And again, 10, oh, we can't see it because I have the calculator in front of it. 10 is weighting it closer to 20 than to like 30 in the second band. And so that's why it's close to 20 and not as higher up, because again, there's more people at that end that's weighting it that way. So when we think about measures of central tendency, we talked about the mean, median, mode, and now we're going to talk with variance, and then we're going to get into standard deviation. We're looking at how is our data spread out. So we have a couple of graphs here. So we've got a normal is where your data is symmetrical, your mean, median, mode all line up. You can have negatively skewed data, which is where your mean is way off to the right, to the left, and your data has been shifted, or positively skewed data. When we talk about a normal curve or a normal distribution, let's see, I'm going to do a normal distribution up here. We have our graph, and let's see if I can make this look nice. So in the middle, we have our mean, and then what we have are standard deviations. So one standard deviation out, we've got 34% of our data on either side. So this is one standard deviation. And we're going to talk about standard deviations in a minute, but I just want you to see the visual. We go another standard deviation out, and that makes up for 13.5% of the data. And then we go a third standard deviation out, and that makes up 2.35%. And then we have the extremes, which are out here, which is more than 3 standard deviations from the mean. And that's where we would look to see where outliers are. And your data, you should only have 0.15% of your data out here for a normal distribution. But we'll talk more about this graph. I just want you to see how under a normal set of data, how it's distributed around the mean. So what is variation? So measures of central tendency don't tell us anything about the spread of the data points. 2 data sets can have the same mean or median, but have drastically different spreads. Measures of the spread are used to assess the dispersion or variation in a data set. And we look at 3 commonly used measures of variation: the range, the variance, and the standard deviation, and the interquartile range. We'll talk about IQR later. So measures of variation just to do with range. The mean gives us an average of list of numbers or data, but tells us nothing about the spread of the numbers in the list. Because of this, we need a measure of variation, in addition to a measure of central tendency. The difference between the largest and smallest number in a sample is called the range, and this is one measure of variation. So when we look at number 1, I want you to identify the largest number and the smallest number and send me what you get for the range. So for our first set, our highest number here is 42. Our lowest number is 6. So 42 minus 6 gives us a range of 36. If you haven't already, go ahead and do number 2. So our highest number is 200. Our lowest number is 59. So 200 minus 59 equals 141. So that's just the range. It doesn't really get into too much about what our data looks like in general. So then we've got the variance. So another method to describe the spread of a data set is to find the deviations from the mean and then derive a measure of variation. The deviations from the mean are found by subtracting the mean from each number in a sample. The sum of all the deviations from the mean, I didn't write that properly, but what I'm saying is that if you sum all the deviations from the mean, you will always get 0. So we're going to do this first example by hand and find the variance and the standard deviation. And then in future examples, we'll use our calculator. But I just want to show like what is the process for finding this. And then from that point forward, I'm not going to expect you to calculate it by hand. So the most useful measure of variation is the standard deviation. Before we look at the standard deviation for a set of data, we must find the deviations from the mean first. This is found by subtracting the mean from each number in the sample. So first, I want you to find the mean. So we've got this set of data right here. I want you to find the mean of that set of data. So if we add these up and divide by 5, we get 46. So our mean is in fact 46. So now when we're looking at this, finding the deviations from the mean means we take the value, the number, and we subtract the mean from it. So the lower values, we do get a negative deviation, and that's okay. So 32 minus 46 is negative 14. 41 minus 46 is negative 5. 47 minus 46 is 1. 53 minus 46 is 7. And 57 minus 46 is 11. And again, if we sum the deviations, we get 0, and this should always be 0. So let's look at calculating the variance, because we're going to use these values. I've transferred them to the next slide. Oh, whoops, it's just below. There we go. So we've got the values, right? So 32, 41, 47, 53, 57. And we found the deviation from the mean. Again, how did we find that? Well, we took the value X and we subtracted the mean from it, right? So remind yourself, X bar equals mean. And then if we want to square the deviation, that means we're taking that value of X minus X bar and we're squaring it. So what I want you to do is I want you to take these numbers and I want you to square them. And you don't have to send me answers. I'm just going to let you work for a hot minute and write those down. And then we'll move forward. So again, negative 14 squared is going to become positive 196. Negative 5 becomes positive 25. 1 becomes 1, 49, and then 121. If I add them up, 196 plus 25 plus 1 plus 49 plus 121, I get 392. So 392 is the sum. So the equation for finding the variance seems, or the formula I should say, seems really intimidating, but these are the pieces to it. So the 392 represents the sum, and that's what that weird E, that symbol means sum, of x minus x bar squared. And all that means it's the sum of the square of the deviations. So then you can see here to calculate s squared, we find the mean of the squared deviations from the mean. And to do this, we're dividing the sum of the squared deviations by n minus 1. So the formula looks like this. And if we plug in our values, we have s squared equals 392, because again, that's what that value is equal to, divided by 5 minus 1. So 5 is the total number of data points. So we have 5 numbers here, right? There's 5 of them. So we're going to do 5 minus 1. So s squared equals 392 over 4. And when we divide that, we get s squared equals 98. So that is the variance. So how does that help us? So when we talk about the variance, it then leads to what we call the standard deviation. So to calculate the standard deviations, we take the square root of the variance. So again, the formula for that is S equals the square root of x minus x bar squared over n minus 1. Again, a really complicated looking thing, but if we take what we got from the previous page, we know that s squared was 98. If we take the square root of that, that means we've got 9.899 or approximately 9.90. So when we think about standard deviation, if we go back to our data, I want to draw what this means. So hold on, let me add in a page. So from our data, so remember we had 32, 41, 47, 53, and 57. And then we have a mean of, what was our mean for this? A mean of 46. So a normal distribution again, we've got so we have our mean here, right? This is our mean, and that is 46. So a standard deviation of 9.90, we're then going to start plotting out. So if I subtract 9.90 from 46, I get 36.1. And if I add 46, or I add 9.90 to 46, I get 55.9. So right, one standard deviation out. So this is considered one standard deviation. And remember, I told you that 34% of your data will lie within there. And then really that's a total of 68% lies within one standard deviation of the mean. If we look at our data points here, almost all of them are in there, like 41, 47, and 53 all lie within that one standard deviation of the mean. If we go one standard deviation out, which means two standard deviations, we're just adding and subtracting on to that. So we're going to take 36.1 and subtract 9.9 from it, and we get 26.2, and then taking 55.9 and adding 9.9 to that, we get 65.8. So this is considered two standard deviations from the mean. And remember this part here, we've got 13.5% of the data. If it's going to be a normal distribution, has to live here. And we can see already all of our data, because 32 is above the 26.2 and 57 is below the 65.8. So all data points in this set are within two standard deviations from the mean. If we were to continue to go out, we would have our last standard deviation point, which would be 3 standard deviations. So 26.2 minus 9.9 gives us 16.3, and 65.8 plus 9.9 gives us 75.7. And this is considered 3 standard deviations from the mean. And this makes up, what did I put, 2.35%? Where's my drawing? 2.35%. And then we've got these weird outliers, and this is the 0.15% that's above 3 standard deviations, and 0.15%, which is below 3 standard deviations from the mean. So again, we can see that our data lies within the 2 standard deviations. So it is really grouped close to our mean. Again, this is just an intro. We are introducing standard deviation to you. We're not going to expect you to draw these normal distributions. That's not going to be something we're testing you on. But if you go on to Stat 216 from this class, this is the world you're going to live in there. So we're just trying to introduce it so that you're aware of what this looks like. So we have calculated the standard deviation. So let's go back to some descriptors. So sample variance is a way to measure how spread out the data is. The sample variance is just the variance in the sample. It gives you an idea of how much your sample differs from the average population or the mean. The variance on its own is not very informative, but we use the square root of the variance to find the standard deviation. So I don't really like this formula. I think this is what is in your book. So for us, we're going to use S squared equals the sum of x minus x bar squared over n minus 1. And then again, to find the variance, we square the deviations from the mean so that the variance is in squared units. To get the same unit as the data, we take the square root, which gives us the standard deviation. And again, I don't like what the book has written, so we're going to use this formula. But again, I'm not going to ask you to calculate this by hand. We did it once to show we knew what we were doing, but in the future, we're just going to use our calculator to do this. The standard deviation is the most commonly used measure of variation. The standard deviation is the measure of variation from the mean. The size of the standard deviation tells us something about how spread out the data are from the mean. So if your standard deviation is a big number, it's really spread out. If your standard deviation is a small number, then your data is very close together. That's all they're trying to say there. So how do we calculate standard deviation with our calculator? So we're going to enter the data into our calculator. So I want you to practice doing this. So we've got 2135, 1910, 1961, 1958, and 2548. Those are our data pieces. So you can tell it says enter your data into L1. So remember to do that, we're going to hit stat and we're going to press enter to edit. We'll clear out the information that we have in there already. And then we'll enter this data. So our first value is 2,135. Our second value is 1,910. Our third value is 1,961. Then 1,958 and 2,548. You'll notice that these numbers are not in order, and that's okay. It doesn't matter. They will figure that out, right? And by they, I mean the little elves that live in our calculator who do the work for us. It does not matter. So then you're going to go to stat and then to the calc menu. So we go to the right and then we want one var stats. And then from here, we are just going to press enter. So let's go to the next page. Oops, I keep forgetting this. I set it up so they're double. So the output you will see is SX. And that's this one right here. Let's see if I can make that. Bring this down a little bit so we can see our calculator at the same time. This is your standard deviation. So that's right here on our screen. The sigma X output, which is the one that's right below it, this is the population standard deviation. The assigned reading in your textbook talks about the difference. We're just going to focus on the sample standard deviation. So to find the variance from this, we've got a few steps. So this is how we get this standard deviation. To find the variance, we're going to do the following. We need to square SX. But we want to use all of those data points. We don't want to just put in a rounded number. I know it's only showing 5 decimal places here, but we want to make sure if it's hiding any decimal places in there that we use it all. So to get to that, we're going to press the vars key. So we're going to do vars. And then from vars, we're going to go down to statistics. Which is number 5. And then we'll press enter. And then we go down to SX, which is number 3. We'll go down to SX. And then we're going to press enter. And then before we do anything, we're going to do the squared key. So we'll hit that, and then we press enter. And then we get the variance, and it spits it out for us. So our variance here is 69,371.3. So The next slide, we've got some set of data. So I want you to use your calculator to find the variance and the standard deviation for the numbers. If you need me to go back to any of the slides, let me know. Again, use your calculator. Don't do this by hand. I showed you once because, again, if you're going to find the variance and standard deviation first, find the standard deviation, i.e. SX. Then do which is SX squared. Okay. And send me your answers to 3 decimal places, please. Okay, so let's do this one together. We're going to hit the stat key. We're going to press enter, and then we'll press up to clear out our work. So we're just going to enter these values. So we've got 7, 9, 18, 22, 27, 29, 32, and 40. Then we're going to hit the stat key. We're going right to calc on 1-bar stats. We'll press enter. And because we only have 1 column entered in there, we don't need to worry about using L1, L2, and all that business. It's automatically going to calculate it for just the first column. And so then we get a standard deviation, which remember is SX in your calculator. And that's going to be 11.339. To find the variance, remember, we need to square that amount. We want the calculator to do the work for us. So we're going to hit vars, go down to statistics. Then we'll go down to SX. And then we'll press the square key and we press enter. And we get 128.571 for our variance. Okay. That's a lot of information that we've gone over today. I don't want to make us go any farther into the lecture. I want to let this kind of sit in your brain. Feel free to look at your homework for this if you want to. Don't forget that you have your exam due today. So if you have not gotten that done, make sure you get that done. And then I hope you all have a good break. So if you don't look at homework over the break, that's fine. I understand. It's not due until Monday, right? So we've got, you can wait until Monday if you want to look at 9.1. Anyways, we will pick back up with this when we come back together on Monday. I hope you all have a good rest of your week and happy Thanksgiving. And I will see you later. Bye.